All right, first thing I want to check is make sure everybody can hear me. So if you can't hear me, um, let me know. Okay, so I was typing stuff just so people could see it. I'm already losing my voice, but I'm going to walk through this stuff through you. You guys should be seeing my screen. If you're not seeing my screen that talked about the class starts at 12:01, that's what we should be looking at now. Um, so for you guys, what I ask you to do is you have a question, either type it in. I have my chat screen up on my other window, or unmute your mics and ask me your question. I do have a few people that have their mics on. And I'm getting a little bit of background noise, so try and mute your mics, or I can mute it for you because I have that ability. Do I? So actually I do. Where is it? I thought I did. All right, I think I just muted everybody. Okay, so are we good? This is like talking to a blank wall, so we'll see. I want to not let you guys know that I had to make a huge sacrifice for you guys, and I'm kind of upset. I did my first class presentation yesterday for Mesa on this stuff, and we wrote code like we always do. And I was informed at the end of it that I can't use my mechanical keyboard because it's too loud. So normally I type away on my mechanical keyboard and I enjoy it immensely. And I have had to switch to an old-fashioned one, which absolutely is okay. So yeah, it's weird switching back. I'm a nerd, I know. So what we're doing today, for those of you that join me, and this is really cool, it looks like I've got at least 16 of you guys here, and I appreciate you joining in, is I want to go over what the final project normally looks like. And excuse me. And then let's look at the tools that you guys have to use to be able to create something in a group project that'll be kind of cool. Okay. So what we're looking at is normally on the final project, we're doing embedded programming on a PIC microcontroller. And so we go through a series of projects and you guys do digital input and output. We learned about interrupts and those are going to be easier now. RGB is going to be really easy for this one. We're going to look at that today. Pulse width modulation is how you turn a digital signal into an analog signal. We're going to be able to use that with our bitmap display that I'm going to show you in a minute. Multiple interrupts we're definitely going to be able to do, but we're going to do them in Mars. Analog to digital and digital analog we can't do because we're doing everything in simulation. We will be able to use a timer, and I can show you how to use a timer. There's a couple of them. Debounce we don't have to worry about because, again, we're not using the PIC microcontroller. So I showed you a bunch of assignments at the beginning of the semester that you guys could do. Candy machines, stoplights, elevators, process control, games, door locks, all kinds of those things. Hold on a second. So what we're going to do is when we kick in the team project, your design will be 40%, your implementation will be 50%, demonstration will be 5%. You'll do that the week after finals. And each person in the group is going to do a summary. And basically the summary is what you did, what the other person did. If it's a larger group, like 3 people, I've had taken points away because you find out one person's not doing anything. So that's kind of where the project is. And there are certain deadlines that we're going to post, okay? And I'm just going to do this is a quick check. Can you hear me? I need at least 2 people to respond on chat and say, yeah, I can hear you. Oh, okay. Awesome. You guys are great. So now what we're going to do is in Mars itself, we're going to start a new project. Okay. And this one right here to just kind of step through. This one we've already done, but you know, in class, but we're going to do it again. And the reason is because now it becomes much more relevant that this is important that you guys understand this one and have a chance to do it. Cody asked, can you guys see the other people's chats? You can, right? Going forward, am I going to need a second monitor? I don't think you are, because the only thing you're really going to do is see mine. If there's a situation where you're going to need to share, are you going to need a second monitor? So how are you going to type? I never thought about that. Are you guys able to put mine up in one side and type on the other side? I had them do it at the MCC, so you guys can split your window. This is being recorded. So Shadi's using two screens on the same monitor. And laptop, it's not enough space. Yeah, some people don't. Okay. That's a good idea. Eric's using his TV. All right. So yeah, this will be interesting. That's something I absolutely did not think about, is if somebody only has one monitor. I don't know. We'll have to play with that. I mean, I am recording this and I will post it. The problem with recording it is it's very possible that I forget to push the record button, which is what I did yesterday. So I meant to record yesterday's session. So I guess if you can't, I mean, to me, you learn more when you type it with me. You guys know that. You really do learn more. So I'm going to leave it up to you. If you have to watch the video afterwards or take notes, then we'll go with that. Okay. Yeah, that's kind of it. Oh my God, this will be fun. All right. So I can make the presentation floating on the screen. I can also pause so people can cut up. All right. So we'll play with this and let's see. And then I'll make some pauses so you guys can surf, MySpace or some stuff like that. All right, remember, we can go to help, and on help, we got all these, this thing right here is what you guys are going to want to make use of as far as syscalls. And in syscalls, this is how we interface with the world out there. We've used a lot of them. You guys have used print integer, print float, print double, all that other stuff. And we did talk about files, whether you use it or don't use it, that's up to you. Right now, we're going to mess with MIDI, and the two syscalls are 31 and 33. The one in the middle, we're really going to need when we do our special projects, which is sleep. And sleep causes the Mars Java thread to sleep for at least a specific number of milliseconds. Time is not precise because it depends on Java's overhead. So what happens here is if you do 31, it starts playing a sound for however long you specify. But it continues executing the program. So you can do a chord if you launch 3 different sounds at the same time. 33 actually sends that note out, but doesn't do anything else until it's finished. So that generates a return upon completion. So it's putting out the note and doing a 32, which pauses. And we're going to play with that in a minute. There's some others in here that I won't cover today that you definitely are going to want to use, possibly want to use in your program. This whole thing is written in Java, so all this stuff here you should recognize from writing code in your classes, dialog boxes and stuff like that. But down here, file IO, there's examples right there. This is the music. I'll come back to that in just a second. That's what we're going to look at. Where did the ones go that I needed? Random. So set seed, random integer, random range, random float. So there's some really, really easy random number generators. So if you guys decide to make a game or something like that, you can make use of that. Okay, so the music one is simply set the pitch, that's an A0. And a C is 60. Okay, so 60 is a C, wherever that is. And G is 67, and A is 69. So whatever, I don't remember music anymore. Duration, milliseconds, is an A1. You put that in A1. And then your instrument, you can pick any one of these instruments. And so playing music is really simple. So, let's, if we want to write a song, so, this is fun with music. Okay, so what we're going to do on this one is just a real simple example is, we're going to do load immediate. Well, it might help if I do what I'm supposed to do, text. Okay, can I make it larger? Yes. Hold on, settings, editor, font size, apply and close. All right, now you got to tell me bigger? I can go bigger. Bigger. Is that good enough? So that was from, okay, cool. So that text, so remember what we've got on this here is A0 is the note. Dollar, God, I can't type, A1. Oh my God, this not use this mechanical keyboard is not a mechanical, it's duration. Okay. Dollar A2 is the instrument. And something was dollar A3, now I don't remember. A3, no, now I don't remember. Shows you what happens when you don't take notes. Syscalls, what was A3? So we got A0, that's your pitch. A1 is the duration. A2 is that. A3 is the volume. So you can actually make music low or small. So this is the volume that I forgot all about. Okay. So what we want to do is we want to light this meeting up, right? So we do load immediate $A0 60. And don't forget this one. This is load immediate $B0 31 3. And this is this is the access we want. The syscall is to play music. So that's the one right there. So we're going to do load immediate $A1. Let's do it for 1 second. Let's do load immediate $A2. We're going to do piano. So this is piano. This is for 1 second. And this one right here is piano. No, not piano. What did I do? Middle C. Is piano 1? Why am I getting confused? All right, load immediate $A3, 50, so that's volume. And we do syscall. All right, load immediate $V0 10, syscall. That should be a program. So unless I mess something up, that should work. So if I run it, save it and run it, now you guys could barely hear it, but on mine, I'm going to turn the speakers up. So you guys should be able to play music with me if you wanted, but this right here, that does a delay. So if I want to do another one right afterwards, I can change it. I can do load immediate $V0 60. Well, we don't want to do it. I want to change the instrument. I want to change the note. So this is A0. And I want to do, let's do, A1, A2. Now I'm forgetting. Volume goes up to 127. Yes. Yes. Instruments A2. So I'm having a senior moment here, but I think I'm going to have a lot of those senior moments. 0, and then A2 is 8. Okay. And then the note is A0, low immediate. No, I still want to do that. So we're going to do this. So I'm just going to change this, and let's do syscall, and let's see what this looks like. That sounded absolutely horrible. Were you guys able to hear that at all? You know what I can do though is I can do this. I can change this to, hey, I got someone playing music. That's cool. Someone's out of tune. Now, if you do a 31, it does it at the same time. So if I do a 31 and then I do that, these two are both going to play at the same time. You couldn't really hear it, but there. Okay, so that, believe it or not, is it on music. What we've got is a big old garbage truck driving by outside. Note, duration, instrument, and volume. And you have to remember that on the syscall, 31 is for simultaneous. Simultaneous. And 33 is for sequential. I know that's the wrong answer. So you can play all kinds of things. You can play all kinds of different instruments. I should be able, I could probably just pick one. And I have no idea what that's going to do. Oh, yeah, it might help if I comment out this stuff. So let's try it. Yeah, that was like a horn. So this is it. This is the first one. It's not too exciting, but it is. I mean, if you're playing some kind of Mario Brothers game or something like that, then it works. That's cool. Okay. Now, what we've got is, so we've got syscall. I'm going to put this online. I have all the help file. I saved it. But we've got this right here. That's not the file I wanted. So what we want to dive into next is we want to look at the next tool. When you go to tools, there's a bitmap display, there's a digital lab simulator, there is a Mars bot, which is really freaking slow, and there's a keyboard display and MMIO simulator. When we looked at memory, if you guys remember that, I don't know if you guys, there's a heap, there's a stack, there's your heap stack, text, data. There's also one area that's dedicated to I/O. And so we're going to be looking at that first. So some of these other ones are things that we're going to get to when we get to the fourth chapter. So let's do one easy first. So the easy one is the bitmap display. And the bitmap display allows us to draw on this thing just like it's pixels on a computer monitor. And each pixel has 3 values. The pixel values that it has are as a portion for red, green, and blue. And the percentage is from 0 to 255 because each one of them is a byte. So we're going to light this thing up a little bit just for kicks and grins. I also want you to notice that you can put your memory for this anywhere you want. When you write to this thing, it's going to update. So for right now, we're just going to use static data to keep it easy, okay? So what we're going to do is, actually, I should do this. Do you guys have any questions on music? So any questions on music? And, okay, good. So now let's write this one here. So we're going to do a new file, and this is going to be fun with bitmap display, okay? And so we're going to light it up. It's really stupid, but it is, okay? Now on this thing, what we have to do is we have to know what we're going to write to, okay? So what we're going to do is, at the very beginning, We can do this a bunch of different ways. We can actually use a memory address, but we'll do it the really cheaty way. We're going to do equib base address 0x10010000. And you should know that this right here matches this over here, so that we know when we're going to write to this thing, this is our constant, this is our base address. So what we want to do is in our .text, we want to store that address somewhere. So we're going to do load immediate $T0 base address. Now remember, whenever you access memory, you give it a base address and you give it an offset. Okay? So that allows you to write to memory, okay? So what we're going to do is to play with it, we're going to just start creating some colors. Load to 0 T1, 0x00, and I'm just going to give an example, FF0000. And what we have to remember is that in color, okay, it's RGB, red, green, and blue. And so what it does is every single color uses 1 byte. This is not used. So when they store in memory, it's going to look at the first byte. That's going to be your percentage of blue from 0 to 254. Your second byte will be your percentage of green, and your third byte will be your percentage of red. So what we want to do is, if we want to make a color that is fully on red, then we give it a full percentage of red, and then we turn off all the others. So what we have to do now is we just have to write this to memory. So we do a store word $T1 0 $T0. Okay, so write the value in $T1 to our bitmap memory. Okay, so that's what we want to do right there. Where can I put it? Now, when we run it, we're not going to see it. We really are not going to see it, especially when I do that. So I'm going to connect. You have to connect. And now, to see it, what I want to do is load immediate $010 syscall. I'm going to run it under debug. So I'm going to compile it. Oh, I better save it first. I'll save as. What is this fun? Fun with bitmap display. ISM. Okay, so I should be able to compile it. No errors, that's cool. So I am going to run it in debug. And the minute I do this, it should have lit up. And you're not going to be able to see it, but there is actually a little red dot right there. So what we're going to do is to make it so we can see it, we're going to make our pixels really big. Okay, so we're going to try that, and then we're going to run it again. And let's see if I messed up. So that's my pixel right there. You guys should now see one big old red spot. So that would count as a really, what's that, pixel art? You always see these people doing pixel art. So what we're doing is we're going to make our pixels really big, because otherwise we don't see them. If you were going to do something really, really artsy-fartsy, you would keep this down to the bottom, okay? So what this allows us to do is we can write any color we want. This right here, that's red. We can do load immediate $T2 0x0000 FF00. So this should be green. Load immediate $T3 0x000000 FF. That should be blue. Now I'm going to ask somebody a question. I am going to throw it out here at 2 people. 0x00. Okay. What color will this display? So if we create one that's full saturation of red, green, and blue, 1 vote for white, 1 vote for blue, 1 person says, I don't know. So let's, okay. And I think that Austin is right that it's going to be black. All right, so I'm going to run this. Watch, I'll lie. Oops. Oh, you know why it didn't show up as anything? Because I actually didn't write it to memory. Okay, I did not write it to memory. Yeah, so what we want to do is we want to write to the next location in memory. So I'm going to store word $T2. What's my offset going to be? Okay, what do you guys think my offset's going to be? First word went into offset 0. So where's the second word going to go? For $T0, same base address. Okay, store word $T3, 8, $T0. Okay, store word $T4, 12, $T0. So if we do that, hopefully, oops, I disconnected. Why did I do that? I'm going to run it, and oh, shoot, I was wrong. So the people that said white are the smart people, and your teacher's the not so smart person, okay? So this was white, full saturation. Yeah, I guess that does make sense. So that's white. Now, what if I want something in the middle? Okay, so if you want something in the middle, what you do is you go to any color picker. So this color picker, anything, you search for color picker online, and you can find any color you want. And what you do, that's really ugly. I like blue, but I'll try and, so let's do a nice puke green, whatever color. So this is our hex right there. So this is the percentage of red, green, and blue. You notice it's hexadecimal. It even gives a percentage right there. For RGB, this is a percentage. So I'm going to copy that, and I'm going to go back to my program, and I'm going to do loading me at $T5, here x00, and this was puke yellow. Okay, so if I try that and compile it and run it, what did I forget again? Oh my God, come on. Store $T5, 16, $T0. So that should work right there. Compile and run, and there's my little puke yellow. Okay, now remember, you can light up the screen all you want, okay? I mean, this right here, so let's do load immediate $T6. No, let's not do load. Yeah, let's do load immediate T6 0. Okay, so this is our I value. Load immediate $T7 30. Okay, and this is our max in our for loop. Okay, so we're going to do a loop. Okay, so this is for loop. Right? So if we want to access all this stuff here, we can't hard code the offset. Offset's part of the instruction. We can't do that. All right, we have to actually do a loop. So this is, end for loop. Right? This right there is where we have to figure out, can we actually go through and write to this image here continuously? So we've got to just tough it up and write a for loop. So we're going to do set less than $T8. So less than as far as $T6, $T7. So this is true if, oops, somebody's microphone, I need them to mute it, please. I'm getting feedback from somebody. Stelline, are you out there? I don't know if you have a microphone. Thank you. I think she has a kid in the background. So this is true if $T6 is less than $T7. All right. So now we're going to do branch equals 0. So our end for loop. Okay, that's going to get us out of Dodge, right? That's our test. You guys have done a bunch. It's hard because we have to think through it. So what we want to do is we want to actually write to memory. So what we're going to do is we'll start from the beginning. We'll do store word, and I'm going to make it ugly. $T5, 0, $T0. Okay, so we're going to write to the address pointed at $T0. Now what we're going to do is error in line 25. Branch equals 0, $T8 in for. Thank you, Austin. I think that should, so it's, I actually have to, I did that yesterday too. Now, what we got, we're doing a for loop. So let's do add immediate, $T6, $T6, 1. Okay, so let's increment our counter. What am I going to do now? Okay, so I want to see how you guys, we have to do one more thing because now we want to continue on our merry way. We can't change our offset. 0 has to stay the same. So since 0 has to stay the same, what has to change? And what am I going to put right there? I can start picking names because I see all of yours, but I want to see if somebody, Lucas or Gavin, what do you guys think I'm going to do? No? Robert, what about? What am I going to do right now? So my address is pointing at 0 right here. But now I need to update my address because the only way I'm going to step through is if I move this word by word by word. So anybody? I'm going to count to 10 and pout. I'm going to drink my soda so I get to belch live on my...
Maybe you can like change the address T0.
Yes. How far are we going to move it? We want to move it
Like
one more.
One more, yeah.
All right. So add immediate. There's a better way to do this, but T0, $T0. What's going there? He's told me that. Someone else. 4. Increment our address by 1 word. Okay. So that right there should, odds are pretty slim, I screwed something up. We're going to take our puke yellow. We're going to start our loop. Anytime you loop, you start your counter at 0. We're just going to go to 30 and see how far it takes us. We're going to do our tests at less than. Now there is one thing here that I forgot to do. So I need one more thing. Anybody else? See if anybody else is looking. So if I don't put this here, then I'm just going to step through this one time and be done.
We need to jump and link back to for loop so that it continues until the end for loop condition is met.
Excellent. Thank you. So we're going to do branch for loop. So let's see if this works or not. So I'm going to run it in debug. There's my code. I'm going to pause for a second because I know you guys are typing. So I'm just learning that teaching this way is going to be really hard, but we'll get to it. Okay, I'll get better at it, I think. All right, so debug. I'm going to try it. I'm going to run it through. So on my step right here, I'm going to use puke yellow. So that's what we're writing. That's what we're targeting at. It's going to go through and update as we always said. So this part right there. Now, let me check something. Not the editor. I don't know if there's a way to make my screen display bigger. So Cody, you had mentioned making I can make the editor show bigger, but unless somebody sees where I can make the actual box, I'll look into that. Anyway, so what we're going to do is we're going to start stepping through this, and we at least did it right. And so what we're going to see is if it updates. And there's our first one right there. So it updated our puke. And then we increment our address by 4 and we branch through. And it should, at this point, and if I go ahead and run it, it ran all the way to here. We'd have to do our math to do whatever we want to do. Okay. I mean, obviously, if you're doing some kind of art, you can do games on this really easy. You can have your just keep track of where you're going to draw next in your background. You have to do it, figure out a way to turn a one-dimensional array into a two-dimensional representation. But that's how we can draw colors. So what it really comes down to is drawing colors, you're going to have to pick your pixel size. And your pixel size are going to have a percentage of red, green, and blue. And then you're going to have a base address that you're going to write to. So we are going to have to, you're going to have to use pointers. My code worked, but I did not display on the bitmap. Did you connect, did you do connect to MIPS? So make sure that when you open up this bitmap display, make sure you do connect to MIPS, and then try it again and see if it shows up. All right. Yes. Yes. So what we can do is I'm going to go here, and I am going to be really loud. This is going to be, let's do this. We want to do it where it just 31, right guys? So what we're going to do is I'm going to copy this, and I'm going to come over here, and in my for loop, I'm going to paste it. Now the 31, you know, I don't need to do all this stuff. I can do this just one time. So I'm going to cut this, and I'm going to put it up here. Okay. And now am I using any of the same registers? I'm not. So V0, A0, A1, A2, A3. Down here, I'm not using any of them. So I should be able to, this is going to be really bad. So what this should do, probably, you know what, I better say this because this very well could freeze up my computer. Because this is going to do a syscall every single time. The syscall will go with the note, because what this syscall does is it uses everything that's in here. It uses V0, A0, A1, A2, A3. This thing, my bitmap display, is not using any of these registers. Okay? So just to be, yeah, and you know what, let's just do it this way. Just to be safe, because I really do think I'm going to blow this up. I'm going to do a syscall right here. And then I'm going to do a syscall right here. Now let's change the instrument. Loading me at $82, 32. And all right, so what I'm going to do is I'm going to test it. I'm going to reset this thing. I'm connected. I'm going to compile it. So it played both my instruments and it did my big ugly code. So that, yes, so the big thing is we can do all kinds of sequential processing. So think about teams. Okay, so when you guys come up with your team project, whoever you're working with, you know, one person could be working on how the logic of the game. Somebody could be working on, you know, is there any kind of special effects sounds that are used, or intro or something. You know, and another person could be working on interface. Okay, so that was a great question, and that shows that right there. All right, any questions before I move on to the next one? So any questions? Okay. All right, so what we're going to do is get done with this one, and the next one we're going to use is the Digital Lab Simulator. So what this one has right here is it's got two 7-segment displays. It's got a keypad, A through F, and it's also got built into it a counter. So if you click on Help, we're going to talk about all this stuff right here. What it's got is it's got this little counter that will trigger interrupts. And that's really helpful when we look at this stuff, and that will make life easy. So I don't know if we're going to get to the counter today, but we definitely want to get to the 7-segment display, which is easy to use as long as you understand how that works. And it also, it's actually kind of cool. Okay, that's your 7-segment display. I got to take a minute. I got to pull up a document. So I am gonna start Word. And okay. Now, this thing I meant to have earlier, I am going to publish this. This is our syscalls. Same thing that we talked about there. File IO, all that stuff. Where's the good stuff? This. So what I want to talk about, this right here is the digital lab simulator. I apologize for jumping around. So this is the what we got off the help file. For the 7-segment displays, we're going to use 2 addresses. This one here is the right display. This address here is the left display. It's exactly the same thing as writing colors, right? What we do is you write to that address and it updates the digital display. So we're going to have to know those addresses. So we're going to have those base addresses stored. They both use a byte. So these aren't by 4. This is 1 byte and this is another byte. These addresses are in the MMIO segment, and so you'll see how to write there. This will be easy. We'll do that first. It's kind of cool. The keyboard, once we figure out how it works and you write something, then you'll see that it's not hard to use, but it kind of takes a little bit of learning curve, and we'll play with that a little bit today. The counter, like I said, is later on. So let's start with the 7-segment display. Remember that this is 7 segments, and then this is your period. Now I tested this. What you want to do is you want to light up your segments. So each one of these is a bit. Okay, so what you want to do is everywhere it sees a bit, it lights up here. You guys did this in CSC120, right? Did you guys not light up a 7-segment display? Does anybody remember doing something like that?
Yeah, we did them in Cody's class.
Yeah, so you guys should understand that this is basically bitwise, and it's pretty straightforward to do. So if we want a 1, we want 0.6, right? If we want a 2, we want 5B. So what we can do is we can start a new project, okay? So we're going to use this one right here. So we're going to start a new project, and this is going to be fun with 7-segment display, okay? And so what we're going to do is we're going to write that. So I might as well save it. You know, fun with 7-segment display. All right. Again, we need those base addresses. All right. So we might as well make it simple. .equiv. All right. So this is my right display, and this one right here is hold on. I'm having a senior moment. What was the right? So the right is at 10, and this one's at 11. So I might as well do it. Wait, I don't think I can do this, can I? I'll try it. That was a mistake. Oh, didn't blow anything up. You guys all still there? Okay. And this is .equiv left display 0x 0. Okay. So that right there is how we start. So, you know, what we need to do is we need to be able to write to those addresses. And those are in, I'll show you where they are right now. So let's do load immediate $T0 write display. Okay, and let's do load immediate T1 left display. Okay, and let's do load immediate $T2 0x 06. Is that what it was? I'm having, so I'll come back here. Hey, I have a brain. Okay, so that was 0.6, and then this was 5B. So let's try that. So let's do load immediate $T3 0x5B. Okay, so now it's just store byte $T2 write display and store byte $T3. Oh, 0. No, what am I doing? $0 T0. And this one is $0 T1. Loading it $V010 syscall. Okay, so this right here, let's try it. So compile it, connect to MIPS. Now, and then if I run it, doesn't do a damn thing. So, hold on. So I can't let it run the program. I did something wrong. Oh, that's why. I was wondering why that worked. Okay, thank you. Do you guys see that? So I had to, you guys pointed out my mistake, which was good. There'll be lots of them. Okay, so we're able to actually light up these segments right here to our heart's content. You know, there is going to have to be, you know, I have a program I'll show you at the end of it, but if you're doing some kind of counter, you're going to have to map your counter to the correct display value on the screen. The one I have that if we get to it, I'll show you is how you use the switch statement. But the 7-segment display, now I do want to show you one thing that, especially when we get to this next one, is down here, this is our memory. And this is going to become important as we, can I show this memory? Okay, as we get to these other ones, I love computers. We really need to be able to watch this when we want to read from the keypad. So if we look at those values, this right here, FFF 0000 010 and 011, those 2 bytes right in there are what controls it. So if I basically compile my program and I start running it, and then when I get to that point where I write to that memory address, you'll notice there's a 6 right there, and that's controlling the right-hand side. And then if I do the next step, there's a 5B, so you'll see the 5B right there, and the 06, and there's an actual mapping from each one. Each memory address is controlled just by that value right there, okay? So how you would put the decimal place is we want it to be a negative value, okay? So what we want is if we take 06, okay? So let's do this. 06 equals 0000 0110. Is that correct? Okay. So I believe that if we want to light up the negative, if we want the negative, then we want it to be this 10000110. So what happens is the very last one lights up this. So that would be still 6, and then that would be, I believe it would be 0806. Does that sound right to you guys? Because that's, yeah. So hopefully, if we make this an 886, okay, I am hoping that now it's going to light up that decimal place. So I'm going to step through and see if I actually did the math. And I did, so that 7 segment right there did connect with it. What we can do is we can do the same thing that we did before, okay? So just to see how this works, I do want to show you this as well. So let's do the same thing. So let's do load immediate $T40, load immediate $T5. And if we're going to light up a byte, that would be 255. 255. Okay, so that's the number of different combinations that we have. And so this is going to be our for loop. Okay, and what we're going to do is we're going to see how this affects our screen. So what we're going to do is we're going to do store by T4 into it. So it's going to be a 0. And then we're going to go up to 255 because I want to see how this thing lights up, right? And then what we're going to do is we're going to do add immediate $T4, $T4, 1. All right, so let's increment our counter. I know that's spelled right, wrong, I don't care. Let's update this segment, okay? Let's branch to for loop. So you guys know what I've missed, end loop. Okay, so what we're going to do is we're going to do set less than $T4, $T5, $T6, right? Set $T6 if $T4 is less than $T5, and then branch equals 0 in loop. So what we're going to do is we're going to step through and continuously update this right here to see how it displays. Now, if we run it, it's going to go really fast and we're probably going to crash our computer. So let's not do that. As we go into this simulation, it's really important that we see how some of this stuff works. So before we actually test, I gotta do a check, okay? We doing okay? So if you tell me before I start running, code is ready. For those people that, I know DeAndre, we got to figure out something else. Error in line 18. You know, I did the same thing last night. I did the exact same frickin' error last time. So hopefully. All right. So I've got it. Yeah, I know. I don't want it to run this fast. So if you look up here, you know, let's run slow or fast. Let's just do like 15 instructions per second. It'll probably take too long, but we're going to step through it. I definitely don't want to run it in debug. So I'm going to compile it, and I'm going to run it. And you're going to see that this is actually, every time it changes, the binary numbers lighten up randomly. Okay, but at least it's going at a speed that we can kind of see what's going on. We can slow it down. Why is it not holding? What do you mean by holding? You can pause it at any point, but it's updating. It is, and here's why. Okay, it is. So when $T4 equals 1, it's 1, 2, 3, 4, 5, 6, 7, 8. And when $T4 equals 2, it's lighting up 0, 0, 0, 0, 0, 1, 0. And when $T4 equals 11, what is it going to do? It's going to light up an 8. Okay, so it's going to light up. We could do that. We could definitely do it. You know, that's not a bad idea. Let's do that. The way to get it to stick is to slow our simulation down a lot, or do a sleep. Now, that's a sleep is a good idea, so we're going to try that in a minute. Okay, so I'm going to compile this again, and I'm going to run it one instruction a second. And that's really freaking slow, and we'll go to sleep. So let's do 3 instructions a second. Okay. So that is one way to get, is to slow down our interaction. But I like his idea better, because you guys asked, can we do these things at the same time? And we can. So what we can do right here is we can do, let's do this. Load immediate $T6. Let's do 1000. Load immediate $V0 32. This is the sleep syscall. This is 1 second. Okay, so if we do a syscall right here, the beginning of this, it should pause. So we're definitely going to want to run this at full interaction. So you want, I don't know who MPC Ender is. So who is MPC Ender? Come on, you got to fess up. Matt, okay. I was wondering why you weren't here. He's doing it 1/10 of a second. I'm going to keep it at 1000, so it's a second. So if we do this and run it, did it not stop? Somebody's got to try and see if, so I did 32 because I'm dumb. I was wondering why it didn't work. All right, let's try it again. Now, do we need it? No, we don't need it here. 1, 2, 3, 4. Great idea. Now, be aware, if you're trying to do simultaneous processing, you don't want to use that. So if you want to be able to do other things at the same time, then you don't want to use sleep. You want to use some kind of timer or something like that to make it change, okay? And so there's ways to do that. Do you guys want to see how to actually create a timer? It's actually, we'd have to play with it. Let me do this other part. I think it's important that we get to it. Okay, so that's the Digital Lab simulator. Lots of good questions. Any questions on that? Does your code work? I hope so. Okay. All right. Let's play with a bot. We're actually going to come back to this Digital Lab simulator because when you look at the complexity of them, this next one, these keypads, that one's going to take some work. So I'm going to cheat, and I'm going to go do something more fun real quick. And I'm going to also challenge my good Java programmers, because I want the Java programmers to actually update the code for this program. Because I actually went in and changed it because it's really freaking slow. So when we go here and you go Mars bot, we want to play with this one. And that looks really boring at this point, and it is. What this is where you can draw and move, and it's like a pencil. You can drop a pencil and draw, but it goes really slow. So if you want to render, what is that? What's that thing called with the Etch-a-Sketch? This is like an Etch-a-Sketch. Okay, it's really what it is you can run around and you can drop a pencil on it. So we're going to play with this one just so you guys see kind of how it works. So let's stop this program. Okay, and let's do a new one. And this is going to be fun with bots. Okay, and so we're going to need to, so this is .equiv, okay, and we're going to need, so we're going to need the address for commands to the bot. Okay, so that's what we're going to get right there. And the first one is that we have to do is we have to have heading. Okay, and this is 0x, I'm going to be lazy, 0x12348010. And this is .equiv, and this is leave track, and this is 0x FFFF 801 or 20. And this one is .equiv, can't type, and this is where x. And if you don't kind of think about, you need to know where your bot is. 0x12348030. And you're going to need to know where your y is. Where y. 0x12348030. Okay. And I should put one now where you do where x and where y, and we should do one called where woof, but I won't be that dumb. .equiv move bot 0x12348050. I got a mistake, don't I? Is that right? Okay, yes, you are exactly right. Okay, so those are going to be our base addresses, okay? Those are going to be what we need to make this do its thing. So in our .text, we're going to need those. Load immediate $T0, heading, load immediate $T1. Let's make it easy right now. Load immediate $T4, move bot. Okay. So what we can do is if we want the heading, leave track, move bot, we need to put values in there that it can read. So what we're going to do is we're going to do load immediate $S0 90. Okay, so we're going to run at 90 degrees. And we're going to do load immediate $S1 1, which means leave a track behind. So this is definitely not leave no trace. Okay, and we're going to do load immediate $S2 1, which is the command to actually move. Move, darn it. Okay, so now we have our commands to it, and what it really comes down to is now we have to load up those values to make it do something. So this is really what it comes down to is, so we are going to do store word $S0 $T1. All right, store heading, store word $S1 $0 T1. So we want it to leave its mark, and store word $S. Ooh, no, I'm right. 2 $0 T4, and we want to command it to move. Right, and then we are going to do this. I like what you guys are going to load immediate $V0 32. Where is heading? So the heading is to the right, it's 90 degrees. Straight down should be 180. Straight up should be 0. How do we get rid of the floating box that pops up when you start typing? It takes way too much real estate. What float? Oh, you mean right here? So when you start this, that? Okay, so if you want to get rid of that, are you telling me to get rid of it? Okay, so mine's gone. So did you see what I did? Are you trying to get rid of yours? Okay, so let's do load immediate dollar $A0 1000 syscall. And now let's do load immediate dollar $S0 127. And let's do load immediate dollar $S1 0. And I'm store word, well, no, I did that wrong. No, I did it right. S0 $T1 store word dollar $S1 $0 T2. Okay, and then let's do another syscall. And I don't know if this is going to work or not. We're going to, I've been playing with this one. I tried to find documentation on this out there in the world. Hold on a second. So that would be the end of the program. So what I want you to do is go to settings and go to editor. And on editor, there's pop instruction guide. And you want to make sure it's clicked on no pop up instructions or directive guide. And then click applying codes. Okay, so you're saying should it store word T0 which line number are you looking at? It should okay. So what we've got is S0 as the heading is 90. That should be T0. Thank you. And then that's T1, that's T4. Okay, so I'm gonna save it. Better save it. Fun with bots. Okay, first see how many mistakes I have. Now I'm gonna have to do this. What am I doing? Fun with computers. Done with that. I don't need that. There's my bot right there. Okay. So I'm nervous, but I'm going to run it, see what it does. So it should, there it's running for 1 second. And then it's going to keep running forever. Oh, you know why I didn't stop it? Might help if I actually stopped. So I got a couple problems here. One, it didn't stop. Two, it didn't change my direction. So what we need to do is after this, let's stop it. So let's load immediate dollar $S2 0 store word dollar $S2 0 $T4. So let's see if it stops. And then we got to figure out what I did wrong here, because I was hoping to change the direction and I didn't get, oh, same thing. I did the exact same mistake, didn't I? So that's got to be T0 and that's got to be T1. And then let's do load immediate dollar $S21 store word dollar $S2 0 $T4. Okay, so I don't know what this is going to do, but I'm going to give it a chance. That's the bottom. That good, Shadi? So I'm going to wait a minute. All right, ready? Pilot, run it, and it changed and it turned the track off, and it's going to go forever because I didn't stop it. So what I could do is I could repeat this up here. So I could copy that, and then down here I could paste it. I know this isn't the best way to do it, but I'm going to try it and see what it does. So that's what that did there. And again, I never stopped it, so it's going to go on forever. Okay? All right. I have two more that I'll show you, but I'm going to post them on Canvas. Actually, no, I've got them. Do you guys have access to the Google Drive, right? I gave everybody a link to that Google Drive. Is that correct or no? Okay, so I am going to put two files there so that we can look at how these work. They're pretty long and I'm playing with them a little bit. So you're going to need to look for mmio test.asm, and you're going to need to look for bitmapsimcounter.asm. And so give me a minute. It's going to take me a minute to get them put on there, but I will go work on that right now. I got to get this hidden. What did I name that folder? Does anybody remember what I named that folder? I think I found it. Okay. Hey guys, Shay, I can hear you guys. All right, there should be two files. Can someone go look and see if there's two files there? And the one I want to open is mmio test.asm. So All right, I'm gonna put them, I'm gonna go a second route. So the second route I'm gonna do is on our Canvas course. I'm gonna put them at the very top where it says WebEx class link. So that I ran into this yesterday. So I'm gonna go to Canvas um, and um, I am gonna do MMI test. Believe me, this is faster than typing it all in. Um, might help if I log in. All right, in Canvas, where it says WebEx class link, when you go to modules, you'll see MMIO test.asm and digital lab sim. So yeah, so I can post the bot program. That's just it right there. Oh wait, hold on. But yeah, I can post that. I'll post that. Somebody says they're having a runtime exception on which program? So command it to move. Line 21. So let's get that one working. All right, let's see if we can get the bot program working for you guys. Give me a chance to take a breath. If somebody, so some people are runtime exception, line 33. So, I mean, who does not have the bot working? Okay. Shadi, I don't know how close you guys are. Lucas, you don't. All right, well, let's go through it. Let's double check. Okay, so we got fun with bots. So make sure these are right. So let's start from there. And then let's just kind of step through this. So the first time we loaded up T0, T1, T4 with our heavy, so Philip says his is working. And then, tell you what, Shadi, you got yours to work? All right, good. Cody, how close are you are? Because I know that you're sometimes a little further behind than the rest of us, which is, Lucas, you got yours working? Yeah, I know. Well, I'll post the code for you. Okay, so that's fine. Okay, so what I want to do is I want to look at MMIO test, the last 3 lines. Nobody's checking spelling in this chat thing, so. Austin, let me know when you're good. I can scroll up or down. Gives me a chance to stop talking for a minute. I'll go check my email. See how crazy this world is. Oops. Yeah, it's also in Canvas. So I put it in the modules in Canvas, and I put it in the Mars Final Project sample programs. Okay. All right. Now, what we're going to do, are we ready for me to kind of go on here? Is I'm actually going to document this stuff right here. So what we've got, I'm going to go to, let's start here, is this looks scary at first, but it's really not horrible. And when we get to the interrupts, it'll be easier. So the biggest thing is we have a 7-segment display. So when I go back to our tools, we're going to look at this right here. And this is the thing we want to check on. It consists of 4 rows and 4 columns. Okay? And so when we're writing to this thing, we have to say which row we want to check. And it'll actually check 1 row at a time. And it's going to tell us if anything's pressed or not. And so there's ways that we have to do that. So if you look at the instructions, byte value at address 0012, whatever, command row number of hexadecimal keyboard 0 to 3 and enable keyboard bit. That's what it's used for. What it really means is if I write a 1 into, if I set the first bit, it's going to say, did anything in row 1 get pressed? If I set the second bit, it's going to say, did anything in row 2 get pressed? Third bit, row 3. Fourth bit, row 4. There's only 4. So in this destination right here, if I write a 1 to that memory location, it's going to send back whether anything was pressed. If I write a 2, it'll send back what anything is pressed. It writes it back into that location. If nothing's pressed, this will be a 0. If anything's pressed, okay, and then what it does is when it writes back, it tells me which one of them was pressed. So each one of those keys at 0, 1, 2, 1. So for example, key number 2 returns a 4, 1, meaning that it's column 3, row 1. Now, why they did it that way, who the hell knows, okay? We're not doing interrupts yet. We will do them, and that'll make it easier. But for right now, we're just going to look at how do we get the information from 12 and 14. Okay, that's really what we're looking at right now. So what I have to do is in my code right here, okay, this is the address to prompt the simulator. Okay, this is the address of the results. okay? This is something else totally different. So we're going to learn how we can take what's entered and write it to something else, okay? Probably covering too much. Hold on a second. No, I picked. Did I mess up here? No, I have the wrong program. All right, I'm done. Let me look at the other one first. I'm getting senior moments right now. So this one isn't using 12. I'm going to load the other one. What was the other one called? 6. This one I think is the one I want to do. Bitmap sim counter. This is where it uses interrupt. This is really cool. What this is doing is this is using an interrupt. And what happens on an interrupt is every time an interrupt gets thrown, it'll actually jump to an interrupt routine, which you guys haven't learned about yet. And we could do something. So if I look at the help file, I'm going to quit after a minute because I'm running out of brains. This right here, which I know you can't read, if 13 is set, that memory location, then every 30 instructions it throws an interrupt and we can do something. Okay, and I'll explain that next time. In this one, all I'm doing in my interrupt, this is K-text, that's my interrupt routine. I'm going to add 1 to T1. So every time, every 30 instructions, I add 1 to T1, and then this is called return from interrupt, which we'll learn about. What you will guys recognize is, look at this. This, you guys should recognize that my counter is going to go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you guys have the code. Here's my case statement. If it is a 0, then I write 03F to my counter. If it's a 1, I write 06. If it's a 2, I write 05B. So this translates a numerical value to the correct representation on the display. Okay, so that's kind of nice right there. This is a routine called update display. I haven't, got a lot going on right now, guys. So I haven't documented like I should. You know, this is a subroutine. Okay, so what I'm doing right here is I set everything up. I get everything pretty. I update my display, and then I enter into an endless loop. And I keep checking T1 to see if it's updated correctly. And if it is, then I update my counter. I'm going to run it. We're going to look at it next time, but it's for you to look at. I'm also going to make it better. I need to document it, but let's see if it works. Remember I said that you can use sleep, but that freezes everything. So if you don't use sleep, it works better if I connect. On. It's really slow right now. Boy, is it slow. So anyway, yeah, take a look at that one. All right, so guess what? I got nothing left. So an hour and 30 minutes of talking. So at least in class, I can just say, hey, you guys go write code. So, one last thing, hold on. This is important. Yes, they should all be there. How many .asm files did we create before I gave up? Okay. So you should have a place to upload your files. If you don't, let me know, and that means I messed something up. All right, so Austin, you said, what is bitmap sim counter supposed to do? What this does is it's using a counter, an interrupt counter, to update my display. So what it's doing is when I connect, every 30 instructions it throws an interrupt, which we haven't covered from one thing to another. So what it does is, Austin, you took CSC230 and you know interrupts in Java. Is that it? So what it does is every 30, it says, screw it, I'm done. I'm going to jump down here and I'm going to execute this code. So every 30 instructions, this code, I can make it anything I want. I'm going to update T1 by 1. And then I'm going to return for my interrupt. There's a lot more that I have to do. So what it's doing down here is it's taking T1 and dividing it by T0. So T0 is 1,000. And that's way too slow right now. So I'm going to change it to, or 10,000. I'm going to change it to 1,000. So what it does is it divides T1 by T0. And if it's not time, then it jumps back to loop. But if we get to where we're saying, okay, I want to actually do something, then I don't know what this is doing. So I did this yesterday and now I can't remember. Oh, you know what this is for? I'm doing this across two displays. So this is, do I have carry over from the right display to the left display? So what I have to do is I'm going to update what's on the right-hand side, but when it gets to the 9, I've got to update what's on the right. So this right here is simply my carry. Am I updating the right-hand side? Down here then is just getting my values, and I update my display, and I loop, and I keep doing this forever. So theoretically, I change it so it should be faster. 1, 2, 3, and there it's really sporadic. It has to do with the simulation. So if we're looking at number of instructions, we're actually going to learn from CPI. So that's what that one's doing, is it's using interrupts to update these two, right? Okay. Any problems uploading your code for extra credit? You should at least all have some. You may not have all of it, but you should have some. We wrote some easy ones in the beginning. Okay, this fun with sound was pretty straightforward. The bitmap display was pretty straightforward. So that's, I just created an assignment on Canvas. So can anybody, Okay, that's fine. I'm going to add it under those modules again. So web class link. So it also should be where it has under modules the web class link. You should be able to get to it from there. Okay. I will do this again on Thursday. There's still one that we haven't covered. This is this one. And what this allows you to do is instantly read data. And then you can just, this over here is for ASCII games. You can move stuff around. This is, right now, if we want to read from the keyboard, we do a syscall. So it doesn't happen immediately, okay? So with this one here, we're going to look at some code on Thursday. I feel sorry for those people that aren't bothering to show up, but I can only make it optional. Now I don't remember what I called it. Might be this one. And it's not. All right, I'll figure it out. Is that still running? All right, all I got. Any questions? We roll live on Tuesday, but hope to see you Thursday. And typing without my mechanical keyboard sucks. And I am so spoiled, but it's too loud. No, I am going to send out a message now. There is definitely class on Thursday for CSC230. All right. That one there, we got a lot of flexibility. So for you people, for all the ones in 240, you know, it's a survey class. It's an introduction to programming languages. So we can just get some good programming assignments done and get an introduction to Prolog. And that one, I think, is, you know, we got to do some work here, but I think 240, we're going to make, you guys have a lot of stress on you. You guys have so much stress on the world. So I'm going to make you do some work, but I'm going to make that one kind of that one's going to be the easy class. Sorry, this one's not. All right. Anything else? Also, I forgot to tell you, if for any reason you can't attend this, you guys can sit in on the Monday, Wednesday MCC class because it's the same thing. We all just listen to me talk. So I'm going to do the second part of this tomorrow with MCC at 1:15. And the rest of the semester, if you want to sit in that class, I can give you the code, and I'm going to be doing the same thing. So, all right. Yeah, submit what you got now. As long as you've got, you know, something for all, I don't care if it works or not. That's cool. No, well, wait, hold on a second. So Roberto, you wrote the theme song. Make it work. I want the working thing. Send me the ones that work now. So Cody, you should have at least 2 that work now. Or within the next hour. Because fun with sound and the bitmap display. Oh, not, yeah. try. I mean, none are fully finished. I'm going to need to rewatch the video. Okay, yeah. Well, all right. I'll tell you what, Cody. You don't need to upload it now, but I do have an assignment for you. Okay. I'm going to upload the video to YouTube, and I'll put a link on Canvas, and I want you to test it and see if it works, and let me know. Okay. So I'll post the video. Probably take an hour. And then you got to send me a message in Canvas and tell me if it worked or not. And if you guys want to see the MIPS Mars Lights Out game, now I've got to copy that link. Wait, what does that say? Oh, that's a clip. All right, so let me go. I'm going to end this. So this is so long until I got to come up with a really corny ending. Well, you know what it is. No, you don't need to document the code. Never do anyway, Travis. I'm kidding. You do. So write code. Be happy. You guys have 3 hours. You have 3 hours of freedom left. Enjoy it while it lasts. And if you don't know what I'm talking about, then you're in a closet. 5 p.m. lockdown. All right. All right. Signing off. This is going to be really bad that this is on YouTube. Meeting's ending. How do I end it?